And the other observation I found here, after passing through KOH, volume fell by, volume again fell. This time he noticed that volume fell by how much? 18 cc, let us say 18 cc. So here notice two observations, two works done. First, before the reaction, after the reaction, change in volume. And after passing through KOH, the volume further decreased by 18 cc. What he is saying is, we this time took the mixture of methane and ethane, burnt in excess of oxygen, and found at the end reaction mixer's volume is more by 4 cc. Next, then that reaction mixer, the products formed, passed through potassium hydroxide, the mixer's volume further decreased by 18 cc. But he says this time the experiment is carried out under different conditions, not at room temperature, at a different temperature where water is in gaseous state. Here the information is that water is in gaseous state. So when water is in gaseous state, that means something like 100 degrees Celsius above or wherever he did, the state only we are important. Water is in gaseous state. So the information is clear that when reaction is performed under those conditions where water is in the gaseous state, before and after the reaction, measurements are done only under those conditions, and he found after reaction volume increased by 4 cc, and on passing through potassium hydroxide it is decreased by 18 cc. So find the individual composition, individual components volumes in the mixture, composition of the mixture. For this, work starts same way, but remember this time methane, oxygen or gases producing carbon dioxide, and even water also not liquid this time. That he mentioned, that is conditions where it is done. That's why here you must consider water's volume also. Whichever is not in gaseous state we ignore, but whichever is in gaseous state or vapor state should be taken into account. So here that the equations again like this, and this time we notice that water must also be taken into account. And what are the information available here compared to previous one? In the available information, total volume of the mixture initially what not given, we can find it, but he has given other two informations. So one you say x cc and other you say y cc in the mixture. Now because here reaction mixer's volume increased, the final volume is greater. It will be x per methane and 2x per oxygen, x per carbon dioxide, 2x per water vapor. Look at that, earlier we ignored that, but this time we cannot because it is also in gaseous state. Then it is y and it is 3.5 or 7 by 2, this time I write y and 2y, and this is 3y. And because the volume set increased, final volume is more. Final volume means products volume, x plus 2x and 2y plus 3y. That is total volume. So x plus 2x plus 2y plus 3y, total volume. Before the reaction, reactant's volume, again x plus 2x plus y, and this is plus 3y. In this way we can understand the difference in volume, and this difference in volume, final volume more by 4 cc he told. So you get the volume of the any one of these two with this, because x gets cancelled and you get y volume how much. So one of the volumes we can calculate here. Next, another information he gave. What is the other information he gave? When this mixture passed through potassium hydroxide, there is a fall in volume. You know, potassium hydroxide does what? Absorbs carbon dioxide. So whatever the difference in volume found, it should be understood as carbon dioxide volume. And according to equations here, what is the total carbon dioxide volume? From equation 1 xcc, from equation 2 2ycc carbon dioxide obtained. Therefore total volume here of carbon dioxide, volume of carbon dioxide, I say x plus 2y, and that is equal to 18. So you can solve now these two and get the answers. X how much, Y how much, or methane how many volume, how many cc present, and ethane how many cc present. So adding those two, you get the total volume also. Like that, depending on the problem there, we must make a solution. But remember, only those three or four observations: change in volume in the reaction, change in volumes on passing through selective absorbents like potassium hydroxide here, and also the change in volume at the end or leftover volume, which is unreacted oxygen volume, and from that also the information we can get required for calculation. So finally, you must understand the reactions are just similar reactions. Any combustion only is not, but combustion reactions are usually used in this, and any other reactions also we can proceed. And finally, for your practice, I will give one more example. This is not for composition. For analysis of molecular formula, we have already done last class, but we have done with two unknowns, one unknown, and even if there are more, information is suppose available accordingly, possible. Suppose there are three unknowns are there, like a compound with carbon, hydrogen, oxygen, say alcohols, aldehydes, etc., organic compound when you take, they contain more elements. Then also same procedure can be adopted. We need some more observations needed because there are three unknowns. We need three observations and do it. Say one compound containing carbon, hydrogen and oxygen is getting burned. For that, we just write the equation comfortably like this: CHXHY OZ, because there are three unknowns appearing. So I wrote like this. And when this is burnt in excess of oxygen, what happens? Again, carbon dioxide, water are formed. And this carbon dioxide and water are formed depending on the state of that liquid or vapor. We consider that is a different thing. But in balancing, we must see that these X, Y, Z, all these numbers, all these unknowns are included. So when you find here 2X and here Y by 2, is Y by 2. So X and Y by 2, 2X and Y by 2, O atoms together give X plus Y by 4. But already Z atoms, ZO atoms are available here. You can write X plus Y by 4 minus Z by 2 oxygen atoms. In this way, the balancing little extra work here. So here it is oxygen atoms. X plus Y by 4 minus Z by 2. Just for your convenience, once again I write this again here: X plus Y by 4 minus Z by 2, so that the oxygen atoms are also balanced. So taking an equation with three unknowns and using similar information that when so many cc of the compound burnt in excess oxygen, this much change in volume found. On passing through potassium hydroxide, this much absorption, this much volume difference noticed. And any other information when found. From that we can evaluate what are these molecular formula of these compounds. So this is simple gas analysis, an important part of stoichiometry. And for your homework, you take this problem like this: 10 cc of gaseous compound with carbon, hydrogen and O elements burnt in excess oxygen. And found to have a fall in volume of 20 cc. Fall in volume of 20 cc. And after passing through potassium hydroxide solution, KOH solution, further fall of 20 cc. If the molecular weight of the compound is 46, find composition, find the molecular formula, determine the molecular formula of that compound. The results are: when 10 cc of this burnt in excess of oxygen, we found a fall in volume of 20 cc at the end of the reaction. Of course, when results are observed at room temperature, notice at room temperature, on passing through potassium hydroxide, a further volume of 20 cc. And then the molecular weight of the compound 46. Therefore, what must be the values of X, Y and Z, so that you can find the molecular formula. So let us end this work with this example, and later next part of stoichiometry we discuss.
డియర్ స్టూడెంట్స్, ఈనాటి ఎపిసోడ్లో గ్యాస్ అనాలిసిస్ టాపిక్ గురించి తెలుసుకున్నాం కదా. మరి నెక్స్ట్ ఎపిసోడ్లో మరో ఇంట్రెస్టింగ్ టాపిక్తో మళ్ళీ కలుద్దాం. అంతవరకు చూస్తూనే ఉండండి KAB టెలివిజన్, ఏపీస్ ఫస్ట్ ఎడ్యుకేషన్ ఛానల్.